Hello, today we are going to discuss about the telephone lines and the WWAN, that is wireless wide area network. So in this we will learn about the telephone lines like the dedicated lines and the dial-up lines. Then we will discuss about the wireless WAN or the cellular WAN technologies like GSM, H or GPRS and LTE. Next we discuss about satellites and BPL technologies. So first we will discuss about the telephone lines. So the telephone lines are of two types, dedicated lines and the dial-up lines. So let's discuss about the difference between these two. So the dedicated lines are also known as non-switch lines. So these lines are always in the on conditions, whereas dial-up lines are also known as switch line. We have to make these lines on before making the access to the network. So these dedicated lines are the permanent and hardwire connections, make the hardwire connections between the two endpoints, whereas dial-up lines are the temporary connection. We have to make the connection to access the network. So these dedicated lines are the type of lease line which we rented from the telephone companies. So whereas dial-up lines are the connection can be initiated manually or automatically in the network. So these dedicated lines have no phone numbers, whereas the dial-up lines have the phone numbers. We have to dial the phone number to make the access to the network. The example of dedicated lines are DSL, and the example of dial-up lines are the PSTN and ISDN. So let's discuss about these. So the first is PSTN, that is public switch telephone network. So this is the dial-up connection. So here this is the old and the slow technology, and it is also known as ports, that is plain old telephone services. So the PSTN is a phone line which is used to connect the landline phones, and it transmits the data with a baud rate of 2400. So these are the basically a phone lines which connects the various landline phones. So here the local exchange carrier, that is LEC, is a telephone company, or we also call it the exchange, which connects the PSTN user with the local central office. And whereas the inter-exchange carrier, IXC, it is also exchange which provide the long distance services, or it provide the connection between the two local central offices. So here the phone lines are used to transmit both voice and data. And CCITT, it established the standard for modem called V standard. So for transmitting the data, we use the modem with the phone line. So here the CCITT, it established the standards for which is known as V standard. So the V standards define the modem speeds, and the current version which we are using of the V standard is V.92, which is offering the speed of 57,600 bits per second. So here the other V standards are like V.22, V.22 BIS and V.32 or the V.32 BIS, etc. So then the ITU, it establishes a standard which define how modem compresses the data and how it performs the error checking. First of all, the CCITT established the standard which define the speed of the modem, whereas then ITU, it established the next standards which define how the modem compresses data and how it checks the error in the data. The next technology is ISDN, that is Integrated Services Digital Network. So this ISDN support digital transmission of data and the voice signal over different line. So here it uses the two channels to transmit the data in voice, that is bearer channel and the delta channel. Bearer channel, B channels, and the delta channel are the D channel. So the B channels, it carries data and voice information using DS0 channel at the rate of 64 kbps, whereas G channels, it carries setup and configuration information which is transmitted at the speed of 16 kbps. So here the setup, which is basic rate interference setup, BRI, it contains the 1D channel and the 2B channels. It is the basic setup which is used in the ISDN network. The next is primary rate interference, PRI setup. It carries 23B channels and 1D channels over the T1 line. So next is the service profile identifier, SPID. So this is the identifier or the number which indicates a specific ISDN number. So these numbers are used to identify the ISDN lines. The next is digital subscriber line DSL. This is a dedicated connection. So DSL is a fully digital and dedicated connection. It supports both data and voice signal over same DSL line, whereas in ISDN and PSTN we are using two different lines to transmit voice and data. Here we are using the same line to transmit the data and voice. So the next DSL SS multiplexer, that DSLAM, is a device that connects the multiple users to the internet, and the SIS is a protocol which defines the internet access through the cable modem. So here the data over cable service interface specification, it is a protocol or standard which is used to define internet access, how to access the internet using the cable modem. So its current version which we are using is GOC SIS 3.1. The DSLs are of two types, that is ADSL and SDSL, that is asymmetric digital subscriber line and the symmetric digital subscriber line. So ADSLs, they work in the same manner, but there is a little difference that ADSLs have the different upload and the download speeds, whereas SDSLs have the same uploading and downloading speeds. Whereas the ADSLs are the less expensive devices, whereas SDSL are the expensive devices. So here the ADSLs use the download speeds up to 15 Mbps and the upload speed is 1 Mbps, and whereas SDSL support the maximum transmission, downloading and uploading speed of 15 Mbps, and the range of speed which is provided by ADSLs are 384 kbps for downloading and 128 kbps for uploading. The second range is 1.5 Mbps for downloading and 384 kbps for uploading, and the third range is 6 Mbps for downloading and 768 kbps for uploading, whereas the SDSL provide the range of speed like 192 kbps, 384 kbps, 768 kbps and 1.5 Mbps to transmit or to download and upload the data. The next is the wireless WAN or the wireless wide area network. So it is also known as cellular WAN. So this WWAN use mobile telecommunication cellular network technologies such as LTE, WiMAX, UMTS, CDMA 2000 and GSM to transfer data. So here the wireless WAN use the cellular network to transmit data between the wireless devices. So these wireless cellular WANs use local multi-point distribution services LMDS or the Wi-Fi to provide the internet access to the various wireless devices. So ISPs offer these technologies regionally, nationwide or even globally. So let's discuss about the various WLAN technologies like GSM, GPRS, Edge, LTE. So here the first is GSM, that is Global System for Mobile Communication. It was developed in 1991 and it gives the speed of 9.6 kbps and it uses the TDM-SS technique, and the feature which we are using in GSM are voice plus SMS or the MMS. The data services which we are using in GSM are SMS and the MMS. So here we are not accessing the internet here. The next is GPRS, that is the General Packet Radio Services. So it was developed in 1995 and is the extension version of GSM which giving the speed of 160 kbps. So here it also providing the data services, that is internet access. The next version is Edge, that is enhanced data rate for global evolution or the GSM evolution or the enhanced GPRS. It is designed to provide the more data speed, that it gives this data speed of 500 kbps. So it provides the voice and data services and the internet access in a more speed. So these are the 2G services. The next is UMTS and CDMA. So this is a 3G generation services. So it provides the data speed of 2 Mbps. It also known as the CDMA 2000 because it is developed in the year 2000 and it used the SS technique, that is CDMA code division multiple SS. So here the subscriber using the code to transmit the data over the ear interface. So here it providing the voice and data services. Also it add the feature of video calling. And the next, the The next generation is HPA plus. So this is a high speed packet SS. It is a combination of HSGPA and HSUPA services. So it is developed in 2007 and it gives the speed of 42 Mbps and it is using the multiplexing technique, that is WCDMA. It is the same version of it is extended version of 3G, which is giving a more speed than the 3G generation technology. The next technology is LTE, which is also known as 4G technology and is developed in 2009 and it is giving a speed of 1 Gbps and it is using the SS technique, that is OFDMA, and with the voice and data services it's providing the high speed internet services to various users. And the next technology is WiMAX, that is worldwide interoperability for microwave access. So these are the broadband wireless access. It is developed in 1999 and it provides a speed of 70 Mbps. So these are technology using the OFDMA technique to assess the to multiplex the data, whereas it offering a features like voice data where it's high speed and it also cover the more distance. So these are the wireless WAN technologies. The next is the technologies like satellite communication and the broadband over power line, that is BPL. So let's discuss about these in brief. So the satellite communication is used in the distant areas such as hilly area. So here we use the to communicate, we use the satellite to in the distant areas. Satellite communication is of two type: one-way communication and the two-way communication. In one-way communication, the user is using a satellite for downloading, whereas for uploading it will use the PSTN or the dial-up connection. In two-way communication, it uses the satellite service for both uploading and downloading. The next technology is BPL, that is broadband over power line. So these services enable internet access through the electrical power grid. So this is the emerging technology. So this is all about the telephone lines and the WWAN. Thank you.